You know, putting a secret API key in the wrong spot? That's how you get your company's entire cloud account totally compromised overnight. Seriously, I've seen it happen. A developer, trying to do the right thing, accidentally checked a key into a public config file. Within hours, boom, attackers had spun up thousands of dollars in crypto mining servers. So today, we're going to build the essential developer toolkit to make sure that mistake, and a bunch of other expensive ones, never ever happens to you. Let's get into it.
Okay, so here's the classic problem, right? It works on my machine. We've all said it. Your app runs perfectly with localhost and your personal test keys. But what happens when you need to run it in staging, or production, or even just on your teammate's laptop? Hard-coding that stuff is just not going to fly. You absolutely need a way to handle configuration for all those different environments without having to rebuild your container image every single time.
And the solution to this whole mess is to externalize your configuration. This is like a core principle of modern software development. Your code should have no idea what environment it's running in. It should be completely decoupled, and that is the secret sauce to making your application portable, scalable, and just way easier to manage.
So what's our first tool for this in the Kubernetes world? It's called a config map. The easiest way to think about it is it's a dictionary. You know, a bunch of key value pairs that live inside your cluster. And it's designed specifically to hold all that non-sensitive stuff, the regular configuration your app needs to get its job done.
So why bother with this? Well, the magic word is portability. You write your code just one time to read a variable, let's say database host, and then the config map just feeds it the right value depending on the environment. It's awesome. Your app can slurp this data up as environment variables or even as files mounted right into the container. Oh, and one quick heads up. There's a 1 megabyte limit. So, config maps aren't for giant files.
Okay, so that's all well and good for regular config. But I can already hear you asking, what about the secret stuff? Passwords, tokens, API keys. You would never put those in a plain text config map. That would be a huge mistake. So for that, we need a totally different tool.
And lucky for us, Kubernetes has an object built specifically for this job, so we can handle those credentials the right way.
This right here perfectly shows the difference. I like to think of config maps and secrets as sisters, not twins. They look similar, they both use that key value structure, and you can inject both into your pods, but their purpose, their whole reason for being, is completely different. Use a config map for your database host and a secret for the password. A config map for a feature flag, a secret for the API key. See? It's a really simple, clean way to separate your concerns.
All right, lean in for this one, because this is probably one of the most misunderstood things in all of Kubernetes. And trust me, it shows up on basically every certification exam. By default, a Kubernetes secret is only base 64 times encoded. Let me say that again, encoded. It is not encrypted. That's a huge difference. It just means it's scrambled a bit. Anyone who can get access to the cluster's data store can easily decode it and read your secrets in plain text. So for real production systems, you absolutely have to enable encryption at rest, or even better, use an external secrets manager. Seriously, don't skip this step.
Okay, so your app is configured and it's secure. What's the next big hurdle? Performance. How do you give your app the juice it needs to run well without it becoming that noisy neighbor that hogs all the resources and crashes everything else on the node?
Yeah, this really is the million-dollar question for keeping your platform stable. Think about it. If one rogue application can just gobble up all the CPU or all the memory on a machine, it can create this domino effect, this cascade of failures that takes down every other app running there. It's a nightmare scenario. But don't worry, Kubernetes gives us the tools to stop that from ever happening.
So the two magic words you need to know are requests and limits. Let's break it down. A request is basically what you're telling the Kubernetes scheduler your app needs just to start up and run. The scheduler then goes and finds a node that has at least that much resource available. The dinner reservation analogy here is perfect. You're booking a table, guaranteeing you have a spot. A limit, on the other hand, is the hard ceiling. It's the absolute maximum your container is ever allowed to use. That's the fire code capacity of the restaurant. If you go over that, well, there are going to be consequences.
And what's really interesting is that the consequences for hitting those limits are totally different depending on what you're using. If you go over your CPU limit, your application gets throttled. Basically, it just gets slowed down, but it stays alive. But if you exceed your memory limit, boom, the kernel steps in and terminates your container immediately. You'll see that dreaded killed error. Knowing that difference is absolutely critical when you're trying to figure out why your app is crashing.
So far, we've talked a lot about configuration and resources, which are perfect for things that run 24/7, like your backend API. But hey, not all code is meant to run forever, right? Some tasks just need to spin up, do their thing, and then shut down.
Exactly. Like, what about that database migration you have to run right before a big deployment? Or a batch job that crunches through a whole day's worth of data? You need some way to run that task reliably, just one time, and be absolutely sure that it actually finishes.
And for that, the Kubernetes job is the perfect tool. It's pretty simple, really. It's a controller that just creates a pod and makes sure it runs until it's completely finished. And here's the best part. If that pod fails for whatever reason, a bug in your code, the node goes down, the job controller will just automatically try again and again until it succeeds.
So the golden rule of jobs is really just reliability. You just tell Kubernetes, hey, run this thing until it's done, and it takes care of all the retries for you. That is so powerful for critical stuff like database migrations or important batch processes. And you can see how this applies to so many different things. We're talking database migrations, batch processing, data analysis, even stuff like sending out a batch of emails or rendering video frames. The list goes on and on. Basically, if it needs to run once and then stop, a job is almost always the right answer. All right, so let's do a quick recap. This is your core K8s toolkit for getting that first application up and running. Think of this as your quick reference guide. For your regular, non-sensitive config, you're going to use a ConfigMap. For the sensitive stuff, you'll use a secret, but please remember to actually encrypt it in production. Then, you'll set resource requests and limits to keep your apps stable and well-behaved. And finally, for any task that just needs to run once and finish, you'll use a job. Nailing these 4 concepts is really the foundation for becoming a great Kubernetes developer. So there you have it. You've got the tools to configure your app, handle secrets, manage its resources, and run those one-off tasks. But what if you need to run one of those tasks on a regular schedule? Like a nightly database backup? Well, for that, you're going to need something a little different. And that's exactly what we'll be diving into next time. Thanks for joining me.